In the space of science and enormous special experiences, the subject of what existed early on to the immense effect has sparked mixed discussions and fascinated characters for a long time. This Goliath demand doesn't simply test how we could unravel the universe, it challenges the farthest objectives of human knowledge. Imagine standing at the edge of existence, looking at the colossal shadowing, and considering what lay there before our universe was conceived. The event of the Big Bang marked the start of history, space, and what we know. In any case, there was a moment before, perhaps a state of nothingness, a silence before the grand cosmic gathering began. And if this is true, was it really nothing? Or maybe something even more unsettling existed before time itself? As we dive deeper into this question, science takes us on a journey beyond the universe's early phase, into ideas that challenge our understanding. Physicist Brian Cox, known for his contributions to the wonders of the universe, proposes that something astonishing could have existed before the Big Bang. He challenges us to rethink our perception of reality and existence. In this exploration, we'll break down the science, the theories, and the intriguing mysteries that could explain what existed before everything. We'll investigate concepts like eternal inflation, quantum fluctuations, dark energy, and even multiverses. The answers we uncover may shock you, but they could also unlock new understandings of our place in the universe. Prepare to dive deep into a world beyond imagination, a realm where the unknown still lingers in the shadows, leaving scientists awestruck and, at times, even unsettled. Let's examine what existed before the Big Bang and why these theories challenge everything we thought we knew. To understand what might have existed before the Big Bang, we first need to examine what the Big Bang actually was. Scientists describe the Big Bang as the event when the universe became incredibly hot and dense, expanding rapidly to trigger the formation of all matter, energy, and fundamental forces. When we look up at the night sky, we see evidence of this fiery beginning, with galaxies expanding outward from an initial point. But why did this happen? Or was there a time before this hot, dense beginning? According to the theory of cosmic inflation, there was indeed a structure before the Big Bang, and it was far from empty or calm. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and free, essentially like a vast vacuum. However, this vacuum wasn't entirely empty. It contained an enormous amount of energy that fueled the rapid expansion of space itself. This expansion, called inflation, occurred so quickly that it essentially set the stage for everything that followed. In a fraction of a second, space expanded at extraordinary speeds until the expansion slowed down and the energy transformed into matter, particles, and the forces we recognize today as the Big Bang. But what was the nature of this energy? Why did it suddenly create the universe? And why did it stop? Scientists believe that this rapid expansion created patches of the universe, each experiencing its own Big Bang. Imagine a fabric stretching endlessly, with tiny air bubbles forming, each bubble representing a universe, including our own. This idea, called the inflationary multiverse, suggests that there are potentially countless Big Bangs and an infinite number of universes. Our universe is just one of many. This mind-bending concept challenges our very understanding of the cosmos and leaves us wondering, what else is out there? The idea of nothingness before the Big Bang is theoretical, not factual, according to our current understanding. Even if we removed all energy, particles, and radiation from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and forces that create a complex tapestry of something. Even in its most vacant state, the universe would still generate new forms of energy. This paradox puzzles scientists because it suggests that true nothingness may be impossible. Space itself has properties, rules, and constants that prevent it from being completely void. Imagine creating a region with absolutely nothing in it. No particles, no radiation, and no energy. Yet, quantum fields and cosmic constants would still exist, implying that even nothingness has properties. For instance, there's a concept called zero-point energy, which represents the lowest possible energy state of quantum fields. In this state, particles can still appear and disappear, creating an eerie fluctuation of activity even in what should be empty space. This challenges our understanding of a true vacuum and suggests that, yes, even before the Big Bang something existed. Scientists are still grappling with this. One of the most mind-blowing theories in modern cosmology is the idea of eternal inflation. If inflation could create our universe, it's possible that it could continue indefinitely. Brian Cox describes a massive inflationary multiverse where universes are constantly being created and expanding. Imagine each Big Bang as a spark igniting another universe, while inflation occurs in different regions, creating countless other universes. This process could, in theory, continue forever. This idea of universes birthing other universes leads to a fascinating concept of a fractal universe, where each new universe may, in fact, create its own Big Bang. Each universe exists as a separate entity within an endless cosmic web. Free space, unaffected by the others. Considering the fast improvement of room for specialists, this theory is both elating and disturbing, as it recommends a relentless multiverse with no unmistakable start or end. Envision our universe being only a smidgen in a giant vast arrangement, continually creating and continuously making new universes. And imagine, what if that is the real essence of reality? There is no before or after, but rather an undying pattern of universes forming. How we interpret nothingness changes when we consider quantum field theory. As exhibited by this hypothesis, the universe isn't a blend of matter floating in space. Rather, it's a complicated association of energy fields that fill the universe, interacting to create all that we observe. These fields resemble intangible oceans, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they remain dynamic. Particles can appear and disappear within these fields, temporarily gaining energy before returning it. This characteristic leads to virtual particles, substances that briefly exist and then vanish, leaving only a faint trace of their presence. The concept of virtual particles challenges the credibility of a true void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you, in fact, have nothing? According to quantum field theory, you wouldn't. Even in a vacuum, fields would remain active, sometimes creating transient particles. This constant fluctuation suggests that the universe does not conform to our traditional concept of emptiness. The fields and forces persist, filling the universe with latent energy that prevents absolute nothingness. This understanding raises a fascinating question. If fields create particles and particles create matter, could the universe itself have emerged from this nothingness filled with quantum fields? Dark energy is a mysterious force that currently drives the accelerated expansion of our universe. But did dark energy exist before the Big Bang? According to some perspectives, the presence of dark energy today is a lingering effect of an energy field that predated our universe's formation. The properties of dark energy suggest a vast, enigmatic force that may have existed in some form before the Big Bang. Some theories propose that dark energy, in a much stronger state, could have powered the inflationary phase, causing rapid expansion. If dark energy existed before the Big Bang, could it have ultimately created the conditions that led to our universe's birth? Could dark energy be the silent architect of expansion, or even the true beginning of our universe? As we examine this possibility, we confront the potential of dark energy not only as a force shaping our cosmos but also as a key that could unlock the secrets of the multiverse itself. Another hypothesis, cyclic cosmology, offers an alternative to the Big Bang as a definitive beginning. This theory proposes that the universe undergoes immense cycles of birth, death, and renewal. In this model, the Big Bang is not a singular event but part of an eternal cycle where universes form, evolve, and then collapse, leading to a new cycle. This theory suggests that our universe may have been reborn from the remnants of a previous cosmos. The process of contraction and expansion in a cyclic pattern would mean there was never a true beginning, only an endless sequence of universes emerging, creating, and regenerating themselves over and over again. Cyclic cosmology raises profound questions about time, proposing that time itself may repeat rather than progress in a linear fashion. If this theory is correct, it could mean that what existed before the Big Bang was simply another phase of the universe, one that collapsed only to give rise to our current cosmos. For scientists, this theory provides a compelling answer to the question of ultimate origins, suggesting that there is no distinct beginning. The universe has always existed in some form, transcending our conventional understanding of time and existence. Gravitational waves present another intriguing possibility for uncovering what existed before the Big Bang. First detected in 2015, these waves are ripples in spacetime caused by extremely massive objects, such as black holes or colliding neutron stars. These waves can travel vast distances, carrying information about the events that produced them. Could gravitational waves offer clues about the birth of the universe? Some physicists propose that waves originating from before the Big Bang might provide insight into the pre-expansion state of the cosmos. Gravitational waves from the early universe could leave traces that help us determine whether the Big Bang was truly the beginning, or whether there were cosmic events before it that we have yet to understand. These waves could be remnants of events beyond our current knowledge. Their existence might hint at a grander structure beyond what we currently perceive. These faint signals could unlock discoveries that transform our understanding, much like the realization that the Big Bang marked the birth of our observable universe. But what if they reveal remnants of a past universe or an event that took place before the Big Bang? As scientists continue to explore the vast reaches of space, the question remains: what existed before the Big Bang? With current theories pointing to quantum mechanics, multiverses, and cosmic inflation, we are closer than ever to unveiling the deep mysteries of the universe's origins. While a complete answer remains elusive, our understanding of what came before the Big Bang continues to evolve with each new discovery. As we investigate these theories, we can also reflect on how they might fit together to form the bigger picture, the true nature of existence itself. Until then, we are left with a mystery that drives science forward, pushing us into the unknown, far beyond what we have ever imagined. As we continue to explore the question of what existed before the Big Bang, time itself becomes increasingly difficult to grasp. Time, as we understand it, began with the Big Bang, making the very concept of before somewhat paradoxical. If time itself did not exist before the Big Bang, can we even discuss something existing prior to it? Some theories suggest that time may not have a clear starting point and that our perception of it might be limited by our current framework of physics. One of the most intriguing aspects of these theories is that they open the door to the possibility of new physical laws, ones that are not yet discovered or even conceivable within our current understanding. If reality as we know it began with a Big Bang, and before that, there was a state of nothingness or cosmic inflation, what governed the forces and particles in that pre-Big Bang state? Could there be an underlying layer of existence that transcends reality, where the known laws of physics completely break down? This metaphysical layer would defy everything we understand about the universe, yet it might hold the answers to some of our most fundamental questions. Some researchers speculate that the universe's beginning might not have been a singular event, but rather the result of interactions between higher dimensional forces. According to string theory, for example, the fundamental building blocks of matter are not point-like particles but one-dimensional strings vibrating at different frequencies. These strings may exist in higher dimensional spaces beyond the three-dimensional universe we observe. If this theory holds any truth, our universe could be just one slice of a higher dimensional space, intersecting with others to form the multiverse. In this scenario, the Big Bang might represent the collision of these dimensions, with a continuous cycle of universes being created and destroyed in higher dimensional realms. Additionally, theories such as the ekpyrotic model suggest that our universe may have resulted from a collision between two higher dimensional branes, membranes of spacetime that exist in multiple dimensions. If such collisions occurred, they might have triggered a Big Bang-like event, initiating a new cycle of expansion and contraction. These models provide a framework for understanding the origins of the universe that does not rely on a single, defined beginning but instead presents a scenario of perpetual rebirth through cosmic events. This idea challenges our traditional thinking about the universe's beginning and opens up new possibilities for its evolution. As our understanding of physics deepens, we may one day uncover the true origins of the cosmos, revealing not just what came before the Big Bang, but the fundamental nature of reality itself.